These are the 3.4 Day 1 notes that we took in class, so I am going to review these with you, and hopefully if you had any questions, this will address those issues. So we started out by talking about a verbal model. So a verbal model is just the word problem portion of a question. So it says that we have this scenario here where somebody sold $48 worth of cheese, and for some reason they forgot how many pounds of each kind that they sold. What they do remember is that Swiss cheese is $8 a pound and cheddar cheese costs $6. So we talked in class about where do we start when we have a word problem, because that was an issue for a lot of you. You were like, I read it, but I don't really know what to do next. So my suggestion and what you should be doing is you want to define your variables before you start. So in our notes, I actually did that for you, and I gave you guidance here on the right side. So it says let X represent the number of pounds of Swiss cheese. So I would expect you guys to define X as pounds of Swiss. And then if you continue reading, it says that we are going to let Y represent the number of pounds of cheddar. Okay, so for Y, you're going to have that one as pounds of cheddar. Now, in a regular scenario, if you were given a word problem and they don't define what they want X and Y to be, it would be your job to figure it out. So in this particular scenario, we could have done either one of these as X or Y, but it's important to be consistent throughout your entire problem-solving process. So that's why you want to go ahead and write it out, okay? So this says that we're going to use our verbal model to write an equation that relates X and Y. So when it comes to this part, what we want to do is we want to think through what we have. They gave me a total amount of money that was spent, okay? So because of that, I know that my equation when I set it up should be equal to that total amount, which was $48, okay? What I also know is that the pounds of Swiss, each pound was $8. So I know that it's $8 for each X that I sold. I also know that it's $6 per pound of cheddar, and it says all this in this last sentence right here. So I know that if I add my cost per pound of cheddar to my cost per pound of Swiss, that it should give me my total cost altogether. So that allows me to write my equation, which would be 8x plus 6y is equal to 48. Okay? And at this point we stopped and we talked about that this is called standard form of a linear equation. In standard form, you have ax plus by equals c. A, B, and C, those are all numbers. A and B can't both be 0, but C can be 0. Okay? All right, so from here, they want us to solve the equation for y. Then we used our graphing calculator to graph the equation. So at this point, we reviewed how to solve for y. So if you have an equation, 8x plus 6y equals 48, and you want to solve for y, that means you're getting y by itself. The first thing that you're going to want to do is subtract 8x from both sides in order to get y by itself. So when I do that, 8x minus 8x cancels, and I'm left with 6y equals 48 minus 8x. So notice I didn't actually subtract here. Remember, you can only subtract like terms. That means since this 48 is just a number and this term has an x with it, I can't actually subtract. Okay? Then from here, the opposite of multiplying by 6 would be to divide by 6. So I have to divide each part of my equation by 6. That gives me y equals 8 minus, and then notice right here, 8 over 6. So some of you are still really struggling with your fractions, and I showed you guys how to use your calculator to help you. So you could do 8 divided by 6 in your calculator. And when you do that, you get 1.33333, so 1.3 repeating. So when you see that, I told you to press Math, Enter, Enter, and it will change that fraction or that decimal back into a fraction. So the reduced version would be 4/3 x. And now you have solved the equation for y. So at this point, we reviewed that this is also a special form of a linear equation, and it's called slope-intercept form. So my slope, or my rate of change, is the number in front of x. In this case, it's -4/3. And my y-intercept, remember that's where the graph would cross the y-axis, is 8. Okay? So we've done B, the first part, and then we used a calculator to graph the equation and look at it. So we put this part of my equation, the 8 minus 4/3 x, into the calculator where it says y equals. Don't forget to put your fraction in parentheses when you do that. So at that point, when we start looking at our graph, we started discussing if the graph makes sense. So we had on our calculator a 4-quadrant graph. But we talked about that with this scenario, really a 1-quadrant graph is what makes sense because you wouldn't have negative amounts of cheese if you're selling cheese. So we labeled our axes, so we said that x is our pounds of Swiss. And remember, we know that because we wrote that up here at the beginning. And then we called y our pounds of cheddar. Okay? Now, when we were graphing linear equations earlier in this chapter, we talked about the fact that you really only need 2 points in order to graph. So that's what we did. We looked at our graph and we noticed, hey, there's some important points here. We noticed that on the y-axis, excuse me, that our graph starts at 8. So we put a point and we labeled it 0, 8. We also noticed that there was a point on the x-axis at 6, 0. So we also graphed that one. Then we started kind of talking about, well, would this data be discrete or continuous? And so we reviewed that discrete means that it's individual data points, whereas continuous, all those little fractions and decimals in between the points would count. Well, we decided to kind of think about this scenario as like a fundraiser. So if you were selling cheese for a fundraiser, you sell it in packages. So we said it must be 1-pound packages, and you wouldn't sell partial amounts. So we determined by looking at our table of values that there was a point that occurred in this middle of these two-ish that occurred at 3, 4, which would also be a valid point. All the other points in our table that fell in quadrant 1 had decimals involved. So we determined that this would be a discrete function because we are saying that these points represent the packages of cheddar and Swiss that we sold. The reason we had that conversation was to talk about this second part of the equation, or I'm sorry, of the problem. So it says, given the real-life context, what's our domain and range? Well, since we determined that this would be discrete, we know that our domain would be all the possible x values. And in this case, that was 0, 3, and 6. We determined that our range is all the possible y values. So in this case, we had 0, 4, and 8. So with this one problem, we have discussed pretty much everything that I've taught in Chapter 3 so far. So this was a very rich problem. We were able to discuss a lot, and we're not quite finished. So the next thing we talked about was what is an X and Y intercept. This isn't the first time that we've talked about this, but it's the first time that we've actually written out a definition on your notes. So the x-intercept of a graph is the x-coordinate of a point where the graph crosses the x-axis. So if you look back at your graph, you should have noticed that the x-intercept occurred at 6. That is where the graph touched the x-axis. Then the y-intercept is the y-coordinate of the point where the graph touches the y-axis. So my y-intercept occurred at 8. Okay? Then we kind of talked about, could we have done this same thing without actually solving for y and looking at our table of values or our graph? And I'm going to come back to this. I want to talk about C first. I'm sorry, that's an E. About E first, explaining the meaning of our intercepts in the context of the problem. So if you think back to the very beginning, this problem was about selling pounds of cheese. We said that X was pounds of Swiss and Y was pounds of cheddar. So my x-intercept was 6, 0. So if we go back to our labels, it will help us interpret the point. We know that they must have sold 6 pounds of Swiss, because that was what the 6 represented in the X part, and 0 pounds of cheddar, according to this ordered pair. On the y-intercept, since it was 0, 8, then that must mean that they sold 0 pounds of Swiss and 8 pounds of cheddar. Okay? All right, we are going to come back and talk about D in a bit, but I want to talk about vertical and horizontal lines. So we talked a lot about vertical and horizontal lines, and in the end, I gave you guys an acronym to try to help you remember some information. So vertical and horizontal lines occur with linear functions or with linear problems in general, and they have some special characteristics. So to help you remember the information, for a horizontal line, I told you to memorize HOI. So the H stands for horizontal. The 0 stands for zero slope, which we'll get more into this in the coming weeks. And the Y is supposed to help you remember that the equation of a horizontal line is always going to be Y equals a number. And you won't actually have an X variable in the equation. So I'm going to show you how to use this on the next slide, but I want to talk about vertical lines also. So for vertical lines, I told you to memorize the acronym VUX. V stands for vertical, U stands for undefined slope, and X helps you remember that these equations are going to be X equals a number. Okay, so a horizontal line is a line that goes left and right, and it's only touching the y-axis. So this y equals should kind of make sense to you. A vertical line is a line that's up and down, so it's only going to have an x-intercept, so the x equals a number should kind of make sense to you as well. So let's kind of look at how we're going to use this today. So if you look at the first example, they have asked you to graph y equals 4. So when you see an equation that says y equals, you should automatically be thinking, oh, this is HOI. Okay? So remember, H is supposed to help you remember that it's going to be a horizontal line. So, and the y is supposed to help you remember that it's y equals a number. So you're going to go on the y-axis to 4, and you're going to put a point. Then you're going to draw a horizontal line through that point. So I know that y equals 4 is a horizontal line that has 0 slope, which we haven't done much with slope yet, but we're going to be doing it, and that it's going to be y equals a number. And in this case, all the y values are equal to 4. So when you see a horizontal line, I want you to think HOI. If you look at graph B, it says x equals -2. So hopefully when you see x equals, you're thinking, oh, that's VUX. So the V is supposed to help you remember that it's a vertical line. So I'm going to go to -2 on the x-axis and put a point and draw a vertical line through that point. I know that vertical lines have undefined slope and that they are going to be x equals a number. So hopefully when you see a vertical line or you see x equals a number, you think VUX. And that will help you remember vertical, undefined, x equals, horizontal, zero slope, y equals. And we're going to do more practice with this, but this is supposed to be a foundation for you guys. Okay, this video is a little bit longer than they normally are, so hopefully you were able to get this one in. If you have any questions, we'll be working on this for the next 2 days, so hopefully we will address them, and if not, please come in for tutoring. You'll have a fantastic evening.